girls. This is our Math 158 homework discussion. And I hope I'm going to be a little bit happier today. I've got some music playing in the background. If it bothers you, tough luck. Okay, test is Tuesday. We're up to section 8.5, and here's some typical homework problems worked out with discussion. Please practice, study, practice, study. Here's number 7. Number 7, root 6 times 3 plus root 2. Go ahead and distribute. So like this, and you should get 6 root 3 plus root 12. The root 12 can be simplified. 6 root 3 plus 2 root 3, and so the radicals are the same. We get 8 root 3. Okay. Number 15. Number 15, we've got root 8 minus root 2 times root 8 plus root 2. Root 8 plus root 2. Okay, you can do this the hard way, but we're going to do it the easy way, noting that this is of the form a minus b, a plus b, sort of the difference of squares pattern, right? A squared minus b squared. And in this problem, a is root 8, and b is root 2. So a squared is 8, b squared is 2, so a squared minus b squared is 6. So that's the answer. Now, suppose we did it the long way around. You could FOIL. So root 8 by root 8 is 8. Root 8 times root 2 is plus root 16. Root 2 times root 8 minus, notice root 16, they go out. And minus times plus is negative 2. So 8 minus 2 is 6. Okay. Number 23. 23. We've got root 5 plus 2 quantity squared. You might be able to do this in your head. I would probably suggest you write it out as root 5 plus plus 2 times root 5 plus 2. And then just go ahead and FOIL. And this is what you get. Okay, root 5 by root 5 is 5. Root 5 times 2 is 2 root 5. Root 5 times 2 is another 2 root 5. That's obviously going to be 4 root 5s. And lastly, 2 by 2 is 4. So this looks like 9 plus 4 root 5. Final answer. Okay, number 31. This is the first one that has variables in it. We shouldn't be too concerned. It says, in the directions of variables are positive real numbers, so no problems with negative square roots. Okay, 3 root x minus root 5 times 2 root x, 2 root x plus 1. Okay, so once again, we're going to distribute or FOIL. Now note that because x is positive, we are going to say root x times root x will be x. We don't have to worry about the absolute value. Okay, so here's our first multiplication. 3 by 2 is 6 root x times root x is x. Second multiplication, 3 root x. Third multiplication, minus 2 root 5x. And the last multiplication is minus root 5. Okay, not much cleans up there. Let me pause this and just take a look, see how the back of the book goes. Okay, back again. That's exactly how the author leaves it. I suppose there are some things you could do. For example, this is 3 root x, and you could write this as minus root 5 times root x. And some people might say, well, let's factor out the root x. I'm not sure that's useful at all, and the author doesn't do that. So let's just go ahead and leave it the way we did like here, consistent with what's in the back of the book. Okay, problem number 35. Number 35 deals with cube roots, which is a little bit more exciting. So we've got the cube root of 2y plus 5 times the 4 times the cube root of 2y plus 1. Okay, and our task is to multiply these together. Cube root of 2y minus 5, 4 times the cube root of 2y plus 1. Okay, so once again, we're going to distribute. So the coefficient just gives us 4, and we have the cube root now of 2 times times y, which really doesn't clean up. There's no triples there. So we're out of that. Second multiplication, we simply have the cube root of 2y. In the middle here, we have minus 20 cube roots of 2y. Okay, so they're going to combine. Yeah. And on the back end, we simply have minus 5. Okay, so here's your cleaned up version. We have 4 times the cube root of 4y squared. In the middle, we have minus 19 cube roots of 2y. And on the back end, we just have the negative 5. Okay. And that'd be that one. And let's look at 39. 39. 39, we have 2 square roots of x plus the square root of y. Notice the radicands are different. And we have 2 square roots of x minus the square root of y. And this is very similar to the one we had just a few problems ago. Let me zip back. It's like this one. Okay, notice that we have a pattern, difference of squares type pattern. So we should be able to get to this one pretty quickly. The A is 2 root x, and the B is root y. So A squared is 4x, and B squared is y. So A squared minus B squared, we can just write the answer down. It's 4x minus y. And again, you could FOIL it out if you like. I'm not going to bother with that particular problem. Let's jump to some fractions. Number 43. Number 43, we've got 7 over root 7. The task is to rationalize, multiply by 1 in the form of 7 over root 7. And that gives us 7 root 7 over 7, or simply root 7. 7's canceled. Typical rationalize the denominator. Here's number 49. We'll do it right next to it. 49, 9 root 3 over root 5. We're going to multiply that one again by 1, this time of the form root 5 over root 5. And we get 9 root 15 over 5. And nothing cleans up there. So that's our answer. Okay, another one has this is problem number 61. We have a negative square root 150 m to the 5th over n cubed. And the task is to rationalize the denominator. Before I do anything, I'm just going to break this up. We've got 150 m to the 5th. And we've got the square root of n cubed. Okay, so the directions say rationalize the denominator. I could clean up the numerator. Notice the 150 breaks up 275, 325, 5, 5. So there's a pair of 5s I could take out. Let me go ahead and do that. I'll also take out the 2 pairs of m and leave just the square root of 6m up top. All that's nice. On the bottom, I'm going to take out the pair of n's and leave the square root of n. To rationalize the denominator, this is the problem that we have to get rid of. So square root of n over the square root of n, that's 1. And here's the cleaned up version. On top, we have 5m squared, square root of 6mn. And on the bottom, we've got n times n, which is n squared. There's one n, and these two form another n. N by n is n squared. So there's your final answer for number 61. Still negative. Don't want to forget that, Joe. Negative, negative, negative. Okay, so that just sort of is tagging around each expression. Okay, number 71. 71. We have the cube root of 4/9, which is the cube root of 4 over the cube root of 9. And again, we could factor these 2 by 2. There's no triples there, and there's no triples here either. But we want to make a triple so that we can have a cube root of 3 factors, and we're going to do the cube root of 3, cube root of 3. There's our multiplication by 1. We now have on top the cube root of 12, and on the bottom we have the cube root of 27, which is simply 3. So cube root of 12 over 3, final answer. Okay. Whoops. I skipped 65. So let me back up and looking at the problem set. I did assign 65. And I also assigned 57. Boy, I was just skipping a number of these floating around here. Let's do both 57 and 65. Sorry for the misread there. 57 and 65. That will get you up to speed. 57 square root 24 over x, root 24 over root x. 24 we could break up. No, 2 goes into a 12, 2 goes into a 6, 2 goes into a 3. There's a pair of 2's. So 2 square root of 6. On the bottom, we simply have the square root of x. The directions did say to rationalize. So we'll multiply by 1 in the form of root x over root x, and we get 2 root 6x over x. Done. Number 65, almost just as fast. No, I did 65. Here we go. So 5 square root of 2m over the square root of y cubed. I'm going to pull out the y in the beginning right off the bat. So this is y, square roots of y, square roots of y. And the problem, again, the direction said rationalize the denominator. So the problem is with this, we got to get rid of. So we're going to leave the 5 root 2m on top. We have y, root y on the bottom, and multiply by root y over root y. And it gives us our final answer, 5 square roots of 2my. And on the bottom, there's a y, and these two make another y, so that's y squared. Okay, back to the bottom of the page. We've done 71. Here's number 75. 75 minus the cube root of 2p over r squared. So minus cube root of 2p over the cube root of r squared. Remember, we need a triple because we're doing cube roots. So I'll multiply by the cube root of r, cube root of r. That will give us our triple down here, right? So final answer, minus cube root of 2pr. And on the bottom, cube root of r is r in my best pirate voice. Okay, number 81. Number 81, the 4th root of 2z over z. Okay, so we're looking for, let's go and break this up, 4th root of 2z over the 4th root of 2. We're looking for triples on the bottom. So when I multiply by 1 this time, I'm going to use the 4th root of 8. And the reason I know that is because 8 is 2 by 2 by 2. That will give me my 4 2's down here, right? You see, all sitting there. So the fourth root of 16 is going to be 2. Up on top, I have the fourth root of 2z8 all over 2. But notice up top, I have 4 2's up there as well. So 2 times the fourth root of z over 2. And lastly, the 2's can cancel. So fourth root of z is the final answer. Okay, feel free to ask questions about that one at the beginning of class on Tuesday. Okay, these are rationalize the denominator problems again. Let's see, we've got number 85. These are going to be using conjugates. Okay, so 85, root 8 over 3 minus root 2 multiplied by 3 plus root 2 over 3 plus root 2. And up top, we got 8 root 3 plus root 16. And on the bottom, because it's conjugates again, a minus b times a plus b. Remember, always results in a squared minus b squared. For this problem, the a is 3, the b is root 2, the a squared is 9, and the b squared is 2. So a squared minus b squared is 9 minus 2, which is 7. And that's what goes right here. One last thing we should note, the square root of 16 is the number 4. So I'll probably write this as 4 plus 8 root 3's over 7. And that would be the best way to do that. Okay, 85, 89. Number 89, we've got root 2 minus root 3, root 6 minus root 5. Use the conjugate on the bottom. And root 6 plus root 5. Root 6 plus root 5 up top, foiling. Root 12 plus root 10 minus root 18 minus root 15. None of that combines. That's just a mess. But out on the bottom, we have 6 minus 5, which is just 1. Okay? Number 95. Number 95, very similar. 91. Skip that. Let's do 91. 91. M minus 4 over root m plus 2, using the conjugate again. Root m minus 2, root m minus 2 up top. You just have to FOIL it out. M, root m minus 2 m's minus 4 root m's, and then plus 8. None of that combines. I mean, I suppose you could put this and this together as m minus 4 times root m, but I'm almost positive the author doesn't do that, so I'm not going to do that either. On the bottom, we have our conjugate difference of pairs again. Notice that a squared is going to be m, and b squared is going to be 4, so I can simply do m minus 4. That's the bottom. Okay. This is rather interesting. I noticed there was an m minus 4 at the beginning. Let me go back and rewrite the numerator like this. M minus 4 times root m minus 2. And notice my denominator, after I've done this multiplication, I ended up with m minus 4, so I can cancel. Aha! And now I get root m minus 2. So it was actually a mistake to multiply that top all the way out. I should have looked ahead and noted that as soon as I threw the conjugate down here, this denominator would have become m minus 4, as it did, and that would cancel with the original m minus 4 up top. Interesting problem. Number 91, number 95. 95. We've got root x minus root y, and we've got root x plus root y. I'll use the conjugate root y. Use the conjugate here, root x minus root y. Keep writing 5. Root y, root x minus root y. Okay, so on the bottom, I know I'm going to get x minus y. Up top, I'm going to get x minus 2 root xy plus y. Notice there's nothing that cancels there, nothing combines, nothing cleans up. Okay, I mean, I did this first part in my head, but you could FOIL it out. Root x by root x is x. There's a minus root xy, and there's another minus root xy. And then negative times a negative is a positive y. And so there's the answer to problem number 95. Okay. 103 is the last one in this problem set. 103 says write expression in lowest terms. This sounds like factor and cancel. So 4 root 8 over 12. Okay, so I see the root 8. I know root 8 is 2 root 2. So the first thing I'll do is clean that up. 16 minus 4 times 2 root 2 over 12. And so that's 16 minus 8 root 2 over 12. And now I'm going to go ahead and factor out the 4. So 4 times 4 minus 2 root 2. And on the bottom, I have 4 times 3. Final answer, 4 minus 2 root 2 over 3. Lowest terms. Okay, that's it for 8.5. I'm going to stop this one, maybe change the radio station, and then we'll try section 8.6. Hope you're having a good weekend. Whoops. Hope you're having a good weekend.